Hello friends and welcome to a new session with edupediaworld.com, your favorite portal for online education. This session we shall start with a new topic, and that is the correlation. So far we have considered distributions related to a single characteristic like the marks of the students, the production quantity of a commodity, the price of a product, and so on. Such distributions are known as univariate distribution. But when various units under consideration are observed simultaneously with regard to two or more characteristics, we get a bivariate or a multivariate distribution. For example, the simultaneous study of the heights and weights of the students, or the production quantity and the cost of a product, the price and the demand of a product, and so on. Even for such data, we can compute the mean or the standard deviation or skewness and so on for the individual characteristic. But in addition to this, for such data we can also determine if there exists a relationship between the given characteristics. In other words, we can say how far the two variables corresponding to the two characteristics tend to move together in the same or in the opposite direction. That is, how far are they associated. So the association between two or more variables is what we are going to see under this topic, correlation. Here we go. We shall study, number one, to determine whether there exists some sort of association between the variables, and if so, what is the degree of association. And this is exactly what we will see under this topic, correlation. In addition to this, for a bivariate or for a multivariate distribution, we may also be interested to determine the most suitable form of the relationship between the variables once we know that they are correlated. And this we shall take under regression after we complete correlation. Alright, so now let's see what is correlation. The formal definition: correlation is an analysis of covariation between two or more variables. In other words, correlation analysis attempts to determine the degree of relationship between more than one variable. The numerical measure of degree of association between two or more variables is called the coefficient of correlation. If there exists correlation between two or more variables, it only implies that these variables either tend to increase or decrease together. Let's say we have two variables, x and y, and if we find that there is a correlation between x and y, it would mean an increase in the value of x would also lead to an increase in the value of y. This is one case. And the other is that an increase in the value of x may lead to a decrease in the value of y. So either they move in the same direction or in the opposite direction. An increase in one is accompanied by the corresponding decrease in the other. if there exists a correlation between two or more variables, then it could be due to one of these four reasons. The first is that one of the variable may be affecting the other. Of course, we may not know which is the one affecting the other, because correlation doesn't give you the cause and effect relationship. What it tells is whether the two variables have a relationship, are they associated, and if so, what is the degree of association. So the one reason is that one of the variable may be affecting the other, or both the variables may act upon each other. There could be a cause and effect relationship between both of them. Even that, if that exists, we will have a correlation. The third is that the two variables may be acted upon by the outside influence. Well, the first two reasons is fine, because we see that somehow or the other both the variables have a relationship. Either one is affecting the other, or both of them are acting upon each other. But in the third case, we see that two variables may be acted upon by an outside influence. There may be a correlation. An increase in the value of one may lead to an increase in the value of other, but still there is no relationship between them. This increase could be due to a third factor which is totally outside the study. An example could be the production of food grain and the use of the fertilizer. When we study these two, we may see that there is an increase, maybe an increase in the use of fertilizer is leading to an increase in the production of food grain. But there may be a relationship between these two, or maybe the correlation or an increase in both of these could be due to the climatic conditions. Well, so what we understand is that at times correlation could even be spurious. It could be just by an outside influence and coincidental. And of course, the fourth is a high value of correlation coefficient may even be obtained due to sheer coincidence, pure chance. So just calculating the correlation at times may not be enough and may not tell us the exact relationship between two. Now let's see what are the types of correlation that we're going to see. When we have bivariate, that is when we take two variables simultaneously, we call it a simple correlation. If we take more than two, it's called multivariate or multiple correlation. Now multiple correlation could be either total or partial. Partial, when we take any two variable at a time from these multiple variables, or if we take all of them together, then it's called total correlation. We shall only be studying simple, that is bivariate correlation. Next, we can have linear or non-linear correlation. Linear in the sense that the increase or decrease is linear, or if they move in a direction, unidirection. Non-linear in the sense if it is not moving in one single line. Let's take these and let's understand using a scatter diagram. Now let me tell you what a scatter diagram is. In fact, scatter diagram is an easy way of understanding correlation. let's say we have two variables, say x and y, and if we are studying the correlation between x and y, let me plot the values of x and the relative value of y here. Say a value of x and a value of y. Say we get something. Now what we see is that when the value of x was say 1, the value of y is also 1. When it increases to this point, y also increase. The increase may not be equivalent, but then there is some increase. Maybe 1 unit of x leads to half a unit increase in y. So we see that there is some increase in these. So when we have an so now what we see here is that the increase is almost linear. So this is your linear relation between x and y. Now at times when we take x and y, initially it may increase rapidly, it may go to a saturation point and then start decreasing. Now this is, we see, is not linear. In fact, it increases once, go to a peak, and then it starts decreasing. So this of course is non-linear. We should only take linear correlation for now. And next is the positive and negative correlation. Let's see what is positive and negative correlation using a scatter diagram. Well, positive correlation means an increase in x leads to an increase in y. Something like this. So this is positive, and negative in the sense an increase in x leads to decrease in y. Something like this. So when it moves in this direction, it's positive, and when it moves downward, backward, it's negative correlation. We shall study a simple, that is a bivariate, linear, both positive and negative correlation. Okay, fine. Now let's straight away go and see how do we measure correlation. The absolute measure is called the covariance. The symbol is COV bracket x comma y. And the coefficients, we have the Karl Pearson's coefficient of correlation given by R, x, y, and the Spearman's rank correlation given by rho. Let me give you the formula, and straight away let's take a few problems so that we understand what exactly is correlation, and we see how do we measure it and how to work about. So let's take the Karl Pearson's coefficient of correlation to begin with. The formula for covariance is 1 over n summation xi minus x bar times yi minus y bar. And the formula to find the Karl Pearson's coefficient of correlation, the coefficient is, the basic form of the formula is covariance of x comma y divided by the standard deviation of x into the standard deviation of y. This is the basic form. When we expand the formula and put it together, we get the form summation xi minus x bar times yi minus y bar divided by root under summation xi minus x bar square times root under summation yi minus y bar square. The other form of the formula, once we multiply these terms which are together and work out, we get is n times summation xi into yi minus summation xi into yi divided by n times summation xi square minus summation xi the whole square, of course the positive root of this, and then the root of n times summation yi square minus summation yi the whole square. How did we get this formula? And how have we got these different forms? We shall take up these in one of the subsequent lectures. For now, let's focus on the working and let's understand how to solve a problem and how to find the value of the coefficient of correlation for a given set of data. So let's take a numerical problem here. As I said, we have two variables x and y. Now this could be either the marks of two different students or marks in two different subjects in a class or anything else. Now let's see how to find the correlation between these two. Well, we shall be using both the formula one by one. Let's take the first one, the first form of the formula, where we are using the covariation directly, and then we shall go to the next form of the formula. So here, let me write the formula once. You have Karl Pearson's coefficient of correlation given by covariance of x and y divided by sigma x multiplied by sigma y. The covariance is given by 1 over n summation xi minus x bar times yi minus y bar divided by sigma x is the standard deviation. We already know the formula. It's 1 over n summation xi minus x bar square times root of 1 by n summation yi minus y bar square. Now what has happened is that we have 1 by n twice under the root here, which can be taken out, and that becomes 1 over n. Both of these gets cancelled, and that's how you got the first form of the formula, that is summation xi minus x bar times yi minus y bar divided by root under summation xi minus x bar square times root under summation yi minus y bar square. So now let's take this formula and let's work out the problem first with this. Now for this formula, first we need to find the means of x and y. So let me first take the sum. the sum of x is 70 and the sum of y is 63, and when we count we have 7 is the total number of data. So the mean of x and y would be the value here divided by 7, and the mean of y would be 63 divided by 7, which is 9. So these are the values of mean. Next I need to find the value of xi minus x bar, that is xi minus the mean of x. And y minus the mean of y. The x here is 12 minus the mean is 10. The value of y here is 14 minus the mean of y is 9. Now let me drag them for all the cells. So here I have the means of x and y, and then I have subtracted them from the given values. Next, we also need to find the square of these terms. So let me do that here in the column in between these two. So you have x minus x mean raised to power 2. Similarly, we need to find for y, so that will be y minus y mean raised to power 2. And that's simply the square of the values in the previous column. Let me drag it down to all the cells down here. So we have the squares of both of these. And what next? Next we need to find the product of xi minus x bar times yi minus y bar. That is the product of this column and the column here. So just let me put numbers here as reference numbers. This is 1, 2, 3, 4, 5, 6, 7. Okay, so here I need to find the product of number 3 and number 5. This will be number 3, column number 3 multiplied by column number 5. Okay, so it will be this multiplied by the one here. Okay, next I need to find the sum of all of these. Let me do that here in this row. So now I have the sum of course x minus x bar is going to be 0, so we don't need that. We need the sum of xi minus x bar multiplied by yi minus y bar. We need the sum of the squares of the difference, and the formula as we have seen here is summation xi minus x bar times yi minus y bar. That is what we have here. Okay, So let me do that. So you have summation xi minus x bar. In our case, our value of summation xi minus x bar is equal to 46. The value of summation xi minus x bar square, let me write that here, summation xi minus x bar times yi minus y bar equals 46. Summation xi minus x bar square, we see here, is this one is 28, and summation yi minus y bar square is 84. So we can put it together like this. We have 46 divided by root of 28 times root of 84. So let's do the working here. We have, of course, we need the square root of these, so let me put it here. Square root of this number, and we also need the square root of this number here. Now we have the square roots. Now it's simple, so my correlation would be the value here, that is 46, divided by the product of these two numbers. And that comes to be 0.94. So the correlation value of these two variable is 0.94, or we can round it off to 2 decimal places and say it's 0.95. Well, this is, we see it's not very complicated, it's simple, but when the numbers are, say, large, again finding the mean and then subtracting them, squaring them, will get very large numbers, and that may lead to some complications in the calculations. Therefore, we go to the next form of the formula and we see that it's still simpler. Now what is the next form of the formula? What we did actually was we multiplied these two terms, and even here we broke this down, and then rearranging we got the next form of the formula, that was n times summation xi into yi minus summation x multiplied by summation y divided by n times summation x square minus summation x the whole square under the root, and then that multiplied by summation n times summation y square minus summation y the whole square. This is our alternate formula. Okay, so now let's solve the problem using this formula, and here we see we need summation of x straight away. We don't need the mean, and we don't have to subtract anything as we had here, xi minus x bar. So we just need the product of x and y, which we have in the ready form, and we need the sums of x and y, and then the squares of x and the squares of y. So first let me find the product, x multiplied by y. and that simply is this value multiplied by the value in the second column. We need the square of x raised to power 2, and also we need to find the square of y, which is simply this value raised to power 2, and here it's this value raised to power 2. Dragging it down to all the cells of these three columns. Here we have all of these. I need to find the sum of all of these. The sum of x first, simply be the sum of the values here. Next, the sum of y, the sum of x into y, x square and y square. So here we have all the sums. You see that the number of columns has reduced drastically, and then putting them together in the formula here, we have n equals 7. So 7 multiplied by summation of x into y. Let me first write all of these here. Summation of x multiplied by y is 676. Summation of x is 70. Summation of y is 63. Summation of x square is 728. And summation of y square is 651. So now we have, and of course n is equal to 7. So now we have all the data. We just need to put them together in the formula, in the form as it is. So the key is to remember the formula, and once I show you the working from here to this and then from here to this, even this would be easy for you to remember. Alright, so let's just see how to calculate it. So you have n equals 7 multiplied by summation x into y, which is 676, minus summation x, which is 70, multiplied by summation y, which is 63. And then that is to be divided by root under n, which is 7, times summation x square, which is 728, minus summation x is 70, so it would be 70 square. That multiplied by 7 times the square of y, which is 651, minus summation of y, which is 63 square. Working this out, now we'll get the value of correlation. So let's do them one by one. So let me first take the numerator. Let me write here. First I'm taking the numerator. Numerator we have n multiplied by the summation of x into y, minus sum of x into the sum of y. We'll put this also in parenthesis. And then the denominator, we have two denominators, one for denominator of one is for x, and the next is denominator for y. Now x, we have square root of 7 multiplied by 728 minus the square of 70, this raised to power 2. This also, although it's not needed. And then the denominator of y would be again the square root of 7n multiplied by the square of y minus sum of y raised to power 2, and the square root is for the whole. So here you have. Now the correlation value simply could be calculated from these data. It will be the value here divided by the product of the values in the denominator. And here we see that we've got exactly the same value which we got using the previous method. Well, so that's all we have in this session. We shall continue with the working of correlation. We shall see the derivation of the formula for better understanding and for ease of remembering it. Further, we shall take the other methods and the other topics under correlation in the upcoming videos. Keep watching Edupedia World videos. Thank you.